Imagine a backyard swimming pool left completely abandoned in the heat of midsummer. On Monday, it's nothing but a stagnant sheet of dark, empty water. By Wednesday morning, if you look closely at the edges, a razor-thin layer of vibrant green skin has begun to blanket the surface. But watch what happens next. By Friday afternoon, that layer hasn't just grown, it has violently duplicated itself over and over and over again, until the water beneath completely vanishes under a thick, living green carpet. Every 48 hours, its entire global mass clones itself. If you leave it alone under the right conditions, it doesn't stop. It doesn't slow down. It just keeps multiplying exponentially. Now, your instinct tells you to look away. We've been conditioned to think this is a toxic outbreak. We've been told it's nothing but choked-out swamp scum that ruins a clean ecosystem. But the biological reality is something that will make you question everything you thought you knew about human survival. This isn't a disease. This is the most hyper-accelerated, nutrient-dense protein source ever discovered on the face of this planet. And a $200 billion agricultural empire has spent the last half-century making sure it stayed buried safely in the mud. Welcome to Roots and Remedies. For millennia, the rise and fall of human empires were fueled by legendary, high-performance survival plants. The Aztecs relied on the resilient, drought-resistant amaranth grain to power their civilization. Ancient cultures across Africa turned to the iron-packed moringa tree to survive harsh seasonal famines. In Europe, Roman legions marched across continents sustained by the incredible protein density of lupin beans. These high-performance food sources fueled humanity long before industrial agriculture existed. But in 2018, clinical researchers at Ben-Gurion University decided to run a groundbreaking experiment. They wanted to pit a completely overlooked, wild aquatic plant against the undisputed gold standards of Western nutrition. They didn't just look at it under a microscope. They isolated 36 human subjects for a rigorous clinical trial. Each participant was fed an identical baseline of 30 grams of pure protein. The sources? Standard soft dairy cheese, organic green peas, and this mysterious, unnamed aquatic plant. To see how the human body actually processed these foods, the medical team drew the subject's blood every single hour for 3 straight hours. The data that came back shocked the laboratory. This wild, unnamed plant didn't just match animal products. It fundamentally outperformed dairy cheese. The hourly blood draws revealed that it triggered a significantly higher spike in essential amino acids within the human bloodstream. Even more surprising, the participants' vitamin B12 levels increased more than either the cheese or the peas. When the final numbers were crunched, the plant locked in a near-perfect 89% human digestibility rating, rivaling the absorption rate of premium animal protein. Yet, a single individual unit of this superfood weighs less than a stray grain of sand. It has no true roots, no traditional leaves, and looks like a microscopic green oval floating aimlessly on still water. In Southeast Asia, where it has quietly sustained rural communities for centuries, it's known affectionately as khai-nam, which literally translates to water eggs. But here in the West, if anyone recognizes it at all, it's dismissed altogether as duckweed. Specifically, a unique genus called Wolffia globosa. And the science inside this tiny speck is about to completely rewrite the rules of human nutrition. To truly understand how revolutionary this plant is, we have to look at its core biology, because it breaks what scientists have considered an absolute, unshakable law of botany for centuries. You see, conventional scientific wisdom states that plants cannot produce vitamin B12. It is a nutrient synthesized strictly by specific bacteria and microorganisms, which is exactly why animal products contain it, and why strict plant-based diets always require artificial, synthetic supplements to avoid neurological damage. But Wolffia globosa shatters this rule completely. When researchers ran the plant through liquid chromatography and mass spectrometry, the undisputed gold standard for chemical detection, they discovered something that shouldn't be possible. Wolffia contains real, bioactive vitamin B12, not the useless, inactive analogs found in certain types of sea algae. The mechanism behind this is brilliant. The plant forms a natural, internal symbiosis with microscopic bacterial endophytes that live directly inside its own tissue. The bacteria produce the B12, the plant absorbs it, and when you consume the plant, you receive highly bioavailable animal-grade vitamin B12 directly from a green leaf. So let's pause and review the baseline facts before we go any deeper. We are looking at a microscopic organism that packs up to 45% pure protein by dry weight. To put that in perspective, that is significantly higher than soybeans at 36%, higher than beef at 26%, and triple the density of traditional quinoa. It delivers all 9 essential amino acids in perfect ratios that meet the World Health Organization's strict standards, and it naturally manufactures its own animal-grade B12 through internal bacterial symbiosis. It is a self-contained, hyper-efficient survival matrix. If this sounds like an experimental concept dreamed up by fringe survivalists, you need to know that the highest levels of aerospace science reached the exact same conclusion. NASA noticed this biological anomaly when researchers working with the National Research Council began testing Wolffia globosa under simulated microgravity conditions for long-duration space agriculture. They wanted to see if the stress of space would degrade its nutritional value. The results, which were officially published in the journal Scientific Reports, confirmed exactly what aerospace engineers had suspected. Wolffia globosa maintains its hyper-accelerated protein production even when gravity is completely altered. According to their official spaceflight calculations, a mere 600 grams of this fresh green matrix per day is all it takes to satisfy an adult astronaut's entire daily protein and amino acid requirement. Think about the profound implications of that data. On a multi-year journey to Mars, you wouldn't need massive, heavy cargo bays filled with freeze-dried food rations. You wouldn't need vulnerable, resource-heavy 90-day soil crop cycles. All you need is a compact, self-contained water tank, simple light, and a microscopic plant that clones its own biomass every 48 hours, producing flawless nutrition indefinitely. Which forces us to confront the one glaring, uncomfortable question that nobody in mainstream media is asking. If a plant this perfect, this hyper-efficient, this incredibly sustainable, and this nutrient-dense exists right now on Earth, why isn't it dominating our global food supply? Why isn't it in every grocery store, every refugee camp, and every backyard garden across the globe? To understand exactly why this superfood was left out of the modern world, we have to pull back the curtain on history and look at the year 1913. That was the year German chemists Fritz Haber and Karl Bosch finalized an industrial invention that would fundamentally alter the trajectory of human civilization: the chemical synthesis of ammonia. The Haber-Bosch process allowed corporations, for the very first time, to manufacture synthetic nitrogen fertilizers straight out of thin air. Before this historical turning point, agriculture relied entirely on the natural laws of biology. Farmers spent generations using manure, complex crop rotations, and native, high-performance plants like amaranth, morina, and lupin beans to naturally fix nitrogen back into the earth and maintain soil life. But synthetic chemical fertilizer destroyed that entire ancient balance. Suddenly, you could dump artificial chemicals onto completely dead, depleted, lifeless soil, and crops would still grow forced replicated yields. By the mid-20th century, this chemical dependency exploded globally, transforming the simple act of growing food into a centralized, $200 billion corporate empire built entirely on recurring purchases. And a wild, free plant like Wolffia globosa represents an absolute, existential threat to that entire multi-billion-dollar economic engine. Just look at the biological checklist from a corporate perspective. First, this plant requires absolutely zero traditional arable soil, meaning you cannot control the land it grows on. Second, it requires no proprietary chemical fertilizers. It thrives by absorbing raw nutrients directly from natural water. Third, it requires no annual purchases of patented, genetically modified seeds from agrochemical conglomerates, because it reproduces infinitely through simple cell division. And fourth, it requires no complex, centralized agricultural infrastructure or heavy machinery to harvest. The suppression of this technology wasn't a dramatic, cinematic conspiracy. There were no midnight government raids, and nobody passed a law banning duckweed. The industrial food system simply did what it does best. It used institutional inertia to starve the alternative. For over 60 years, every single dollar of agricultural subsidies, every university research grant, and every government infrastructure program was meticulously funneled into chemically dependent monocultures like corn and soybeans. If a crop required proprietary chemicals, heavy machinery, and patented seeds, it received billions in funding. If a plant could reproduce for free in a simple tub of water on a concrete rooftop, it was completely ignored and left out of the textbooks. This institutional bias created a bizarre, stark cultural divide across the globe. In Thailand, Laos, and Myanmar, rural communities have harvested khai-nam, literally meaning water eggs, from local, clean freshwater pools for centuries. They toss this highly prized, nutrient-dense superfood into daily stir-fries, mix it into traditional soups, and treat it as an ordinary, natural source of high-performance survival nutrition. It is a staple of self-reliance. But here in the West, systematic cultural conditioning took a completely different path. We were taught through media and marketing to view the exact same plant as nothing more than a nuisance, an unsightly, inedible layer of pond scum that needs to be sprayed with chemical herbicides to keep an artificial backyard lawn looking clean. This negative narrative in the Western world was firmly cemented by a historical red herring that derailed scientific interest for decades. Back during the height of the space race in the 1960s, NASA scientists briefly experimented with a common, large-leaf variety of duckweed known as lemna for space life support systems. However, those specific lemna species contained high concentrations of oxalic acid, a natural plant compound that, when consumed in large quantities by humans, can bind with calcium and cause severe, agonizing kidney stones. Due to this medical risk, the research project was abruptly halted and the public message filtered down into the scientific archive. NASA tried duckweed, and it failed because it's unsafe for human consumption. But what they left out of the public narrative was a critical, game-changing biological detail. The Wolffia genus is completely distinct from lemna, and it does not produce oxalic acid at all. The entire Western scientific establishment had simply abandoned an entire category of global nutrition based on the wrong plant genus. Fortunately, the truth cannot stay buried forever. In 2018, an agile bionutrition company decided to bypass the traditional agricultural gatekeepers entirely. They isolated a premium, incredibly clean strain of Wolffia globosa, subjected it to rigorous, peer-reviewed modern clinical trials, and definitively proved its hyperdense nutrient profile and flawless human bioavailability to the world. By 2021, the European Food Safety Authority officially validated the plant, approving it as a safe, authorized novel food source. The 60-year corporate blackout was officially broken by the power of independent science. At the end of the day, what the industrialized food system fears most isn't a new chemical or a new law. It is a food source that they cannot control, cannot patent, and cannot manipulate for recurring corporate profits. Wolffia globosa shatters their entire economic model because it requires absolutely no corporate middleman to exist. It requires no massive supply chain, no heavy financial investment, and no industrial factory. It just needs a pocket of water, a splash of sunlight, and a single, microscopic cell that knows exactly how to clone itself forever. And the most beautiful part of this story is that you do not have to sit around and wait for the agricultural empire to give you permission to access it. You can participate in this biological rebellion right now, today. High-purity, live Wolffia starter cultures are readily available online through premium aquarium suppliers and specialized sustainable bionutrition brands. You can launch your very own microfarm using nothing more than a single clean plastic bucket or a glass jar placed on your balcony, your patio, or your windowsill. Within 48 hours, you can watch your own food supply actively double its biomass right before your eyes. Now that you know the truth, that the world's most hyper-efficient, resilient protein source has been hiding in plain sight in the wild for 60 years, the question is, what are you going to do with this knowledge? Will you keep relying entirely on a centralized system that profits from scarcity, or will you take control of your own nutrition? If this deep dive opened a new vault of knowledge for you, hit that subscribe button for Roots and Remedies, smash the notification bell, and share this video with someone who needs to see it. Because some solutions are too fast for the system to catch, some powers are too small for them to notice, And the ultimate tool for human self-reliance has been floating quietly right in front of us the entire time. See you in the next harvest.